In this video, we'll look at an intuitive sense of how you work with limits. So what we'll do is we'll take a function here, and we're going to try and figure out the limit as x approaches a particular value. So the function we'll work with is x minus 2 divided by x squared minus 10x plus 16. Okay, and then we're interested in what the behavior of this function is as x gets really close to 2. Now, if you notice, if you plug in 2, then we have a problem. So that we're not actually going to do that. But what we'll do instead is just kind of pick numbers close to 2 and then investigate what it looks like the limit is doing. Okay, so so we'll make a little table here, and I'm going to put a bunch of little bars in to just kind of divide it up. 1, 2, 3, middle, 4, 5, 6. Okay. And in the middle here, so we'll put x is here and f of x is here. And in the middle, I'm going to have 2. And then I'm not going to put anything in this box. To the left of 2 and to the right of 2, we're going to pick numbers that are either to the left or right of 2. So here I'm going to do numbers which are getting really, really close to 2. And then same thing on the right. 0.001, 2.01, and 2.1. Numbers that are bigger than 2 but sort of approaching it. And then in this box here we need to just put f of x. Okay, so I've pre-computed these numbers, but all we would do is just take the x coordinate here, plug it into this function, and then crunch the arithmetic to see what we get. So what we end up getting is about, and I'm going to round all these to 4 decimal places, negative 0.1639 for this one, negative 0.1664 for this one, and then negative 0.1666, and then on this side we see negative 0.1667, 0.1669 negative, and then lastly negative 0.1695. Okay, so what we need to look at is as we get closer to 2, what do these numbers look like they're approaching? Well, it looks like it's about negative 1.666. And when you see repeating 6's like that, you might be tempted to think that they actually should repeat. So, and sorry, that should be 0.1 there. So what we would guess here is that it's about 0.1667, or 6 repeating. Okay, so our guess is that this is negative 1/6. Now we'll look at ways to determine that that's exactly correct later, but it seems like a pretty accurate approximation. Now, knowing that 0.16 repeating is the decimal expansion of 1/6, you may not just remember that, but you can kind of just crunch through it and get a pretty good idea as to why that's true. Okay, so that's the idea for this sort of table version of how to figure out limits. Now we can also understand these things graphically, and so we'll do that in the next little segment. Okay, so in this segment we'll look at a sort of graphical view of limits. So what I'm going to do is take a function here, and they've been kind enough to give me the actual definition of the function. And so this one will be x squared plus 1, provided that x is not equal to negative 1. And if x is equal to negative 1, the value of the function will just be 1. So basically what this looks like is it's just a parabola. So we'll get a set of coordinate axes here. And then let's put this part in red. X squared plus 1 has its vertex here at 1. 1 unit up. And then otherwise it looks like the normal x squared parabola, with one exception, that when x equals negative 1, the parabola would normally want to be 2, but it can't because the function's not defined there, so we'll have an open hole. But otherwise, it'll be the x squared parabola that you know and love. And then the function here was defined to be 1 when x did equal, and that should be a negative right there, negative 1. So what that means is that we have a dot right here. Okay, so what do we think the limit as x approaches negative 1 of this function is? So basically we just need to look at what are the y values doing when x gets really close to negative 1 but not actually equal to it. And so if we sort of trace along the graph here, we're getting closer and closer to this hole, but never actually getting inside the hole. So what's the y value of the hole? We said it was 2, so we should expect that this equals 2. Now notice that this is not the same as just plugging negative 1 into the function. Because if you plug negative 1 into the function, you get 1, and if you what this limit we just computed was 2, and of course 2 is definitely not equal to 1. So asking the question as to what the limit is has nothing to do with the value of the function at the point that you're working with here. It has everything to do with what the behavior is right around that point. Now for nice functions, and we'll talk about this later, these two things do come out to be the same, but there's no guarantee that that's necessarily going to happen, and here's an example where it didn't. So in class we'll just look at more of these and more exotic stuff.